Alright, hello biology students. I just want to do a quick video on valence electrons because I think students are getting confused between electrons and now valence electrons. So electrons are just a all-encompassing broad category. But let's talk about valence electrons. Valence, V-A-L, valence electrons, alright? Now what do we already know about electrons? Electrons are a negative charge, okay? And they orbit the nucleus being the center. So they orbit the nucleus of the atom. Nucleus of the atom. Okay? If you don't know what atom is, or you don't know what orbit or negative charge is, I suggest you watch my video in my YouTube channel on basics of chemistry, where we talk about the protons, neutrons, and electrons and their charges and their masses, and that will help you with this video. But let's move on. So valence electrons, what is their specialty? They're the ones responsible for the bonding of elements together to form compounds. For example, you have H2O, water, okay? If you didn't know, that's an oxygen bonded to a hydrogen bonded to another hydrogen. You can see there's two H's, so I have two H's, and there's hydrogens, and one oxygen, there's one oxygen there. So how do we get this bonding in here? That's where the valence electrons come into place. Alright, so let's look at oxygen. Okay, you look at the periodic table, you look for O, you see that there's going to be 8 above it, atomic number. The atomic number is the amount of protons in there. If you don't understand that, please watch my chemistry basic video. As well as the atomic mass is 16. So you're going to see something like this on the periodic table that you look up. And so now you need to determine your valence electrons. You need to just decide how many are in there. So here's what you do. So we have the nucleus of oxygen. I'm going to write 8 protons, 8p for protons, and then I'm going to write 8 neutrons. Okay, and this is the nucleus of the atom. All right, let me draw like a center here. So this is the nucleus of the atom. Now, we know that electrons orbit around the nucleus. So now we're going to be a little bit more specific. Now they can orbit in specific levels or shells. Okay, you may hear somebody, depending on what chemistry teacher you have, talk about a level or a shell, electron shell or electron level. Okay, so this first level here can have 2 spots for electrons. So this is the first level here, okay? And I'm going to draw the white is representing the orbital pattern, how it orbits or goes around. All right. Now let's say we have an element that has more than 2 electrons. The next level, it can hold 8. So let's draw 8 potential spots. These are kind of like fill in the blanks. Okay, we're going to fill in the blanks here in just a second. All right. Let me draw now. So this next white line, this is the next level or the next shell for the available electrons to orbit in. All right. So we go back to looking at oxygen. Oxygen had 8 protons and it had an atomic mass of 16, but that's not important. But I get this information here from the periodic table. Now we're assuming that oxygen is not an ion. An ion is an element that has a charge on it. So it doesn't have a charge, so the number of protons are going to equal the number of electrons. So protons equal the number of electrons. E minus is electron if you write that in chemistry. So let's do that. So we know that we have 8 protons, and I just told you that if we have 8 protons, we're going to have 8 electrons. So let's put these electrons in the orbital level or shell. Okay? So we have 8, so 1, 2, 3, 4, 5, 6, 7, 8. All right. Now, those who may be a little bit more advanced would know this as the Octet Rule, okay? But I don't want to get too much into the Octet Rule, but that's a good word you can look up on YouTube. Now you can see here in oxygen, we still have 2 available spots for electrons to go, okay? So let's get back to the topic at hand, valence electrons. The valence electrons are all the electrons on the outermost level. So we do not count the inner level, we only count the outermost level. So in our example here, the outermost level is right here. So I have 1, 2, 3, 4, 5, 6. I have 6 valence electrons. Okay? Valence electrons. 6 valence electrons in oxygen. Now, one thing you need to know about the octet rule is an element that doesn't have 8 electrons in its outermost level is not happy. So it's going to try to get 8 electrons in its outermost level so it can be happy, or they like to use the word stable in chemistry. Stable elements don't react or explode too well because they're happy, they're stable. They don't need to do anything. So that's what valence electrons are. They're the electrons on the outermost level or shell of an element, and they are the ones that are going to be responsible for the bonding. My next video is going to cover ionic bonds and covalent bonds. So please make sure you have a good understanding of this video before you move on. I would try another example. Try lithium. Do the valence electrons for that. Try out sodium and try out chlorine and see how many valence electrons you can get for that. I will be going into valence electrons in my ionic bonding video again, but hopefully this real quick thing about valence electrons helps you out, and have a great day.